Mr. Clark here from Clark Maths. So today we're doing the SQA Higher Maths 2025 exam paper 1, which was on the 12th of May between 9 and 10:15. First thoughts on this exam was it was actually quite a fair paper. The last question I think some of you will find quite difficult, a little bit of nuance in there, but in general it was not too bad. Let's get into it straight away. SQA Higher Maths 2025 paper 1, question 1. A curve has equation y equals x cubed minus 2x squared plus 5. Find the equation of the tangent to this curve out at point equals x equals 2. Equation of the tangent means I need to differentiate. So I do the y by the x, and that tells me the gradient. 3x squared, 2 2s is 4, so 4x, and the 5 disappears, and I want to do that at x equal 2. So at x equal 2, the y by the x is 3 times 2 squared minus 4 times 2. 3 times 2 squared is 4, so that's 12. 4 2s is 8, so I get 4. And that's my gradient. Now I need a point. I've got x equals 2, but I need to find the y. So at x equal 2, we've got y equals 2 cubed minus 2 times 2 squared plus 5. That's 8. 2 2s is 4 times 2 is also 8, plus 5, which is just 5. So I've now got my gradient, 4, and my point, which is 2, 5. So I can sum into y minus b as mx minus a. Y minus 5 equals 4x minus 2. Y minus 5, 4x minus 8. So y equals 4x minus 8 add 5 is minus 3. And we're done there. SQA Higher Maths 2025 paper 1 question 2. Find the equation of a perpendicular bisector between 1, 4 and 9, 10. So perpendicular bisector means you need to find the midpoint first and then use m1 times m2 equals minus 1 for your gradient. So let's do midpoint of a and b. So that's when you add the points and divide by 2. Average them out. 1 plus 9 over 2 and 4 plus 10 over 2. 1 plus 9 is 10. So that's 10 over 2 and 14 over 2. That gives me 5 and 7. So there's my midpoint, and then I want my gradient of a and b. So 10 minus 4 on the top and 9 minus 1 on the bottom. 6 over 8, which simplifies to 3 over 4. So we can say that the gradient of our perpendicular is equal to minus 4/3 straight away because m1, m2 equals minus 1. So we've now got our point, 5, 7, and our gradient, minus 4/3. So once again, y minus b is mx minus a. So then we can just take the 3 up, equals minus 4x minus 5, 3y minus 21, minus 4x plus 20. Now you can't really leave it like that, so I'll take the x's to the same side and take the numbers to the same side, so you get 41. That's one option, or you could have 3y plus 4x minus 41 equals 0. Or really, if you really wanted to have y equals, it would be minus 4 over 3x plus 41 over 3. I probably wouldn't bother leaving it like that. And we're done there. Clever Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code CleverMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code CleverMaths. The links are in the description and down below. SQA Higher Maths 2025, paper 1, question 3. Integrate 12 over x squared plus x to the half dx. So I need to get it ready to integrate. So that's 12x to the minus 2 plus x to the half dx. Add 1 to the power, divide by the new power. Minus 2 add 1 is minus 1. Divide by minus 1 gives me minus 12. Add 1, so that's 3 halves. And when you divide by 3 halves, it's the same as doing 2/3. And then you've got plus c. And really, that's it. But I'll probably make it look neater, just for the sake of it. It doesn't tell you to really do anything with positive powers or anything. Minus 12 over x, plus 2/3 x to the 3/2, plus c. You could do as much as you want with that, or as little as you want with that. You could do, if you really wanted to, minus 12 over x plus 2/3, and it would be the square root of x cubed plus c, but I don't really see any need to do that. And we're done there. SQA Higher Maths 2025, paper 1, question 4. 3 log base 3 2 plus log base 3 1 over 24. Rules of logs, log base 3 2, and then the 3 can come up as a power. Plus means times, so that's times 1/24 to get it as 1 log. So that's it as 1 log. Simplify that, that's 8 times a 24th. That's a third when you simplify the fraction. So what does that tell us? Well, 3 to the power of something is a third. 3 to the power of minus 1 is the same as a third because it's 1 over 3 to the 1. And therefore the answer to that question is minus 1. 3 to the power of minus 1 is a third. And we're done there. SQA Higher Maths 2025, paper 1, question 5. The diagram shows the graph of f of x with stationary points at 0, 3, 4, 0. And on the diagram in your answer booklet, sketch the graph of f of minus x plus 3. Now, this is where I think some people will make a mistake. The minus is not in front, so it's not flipping that way. The minus is stuck here, which means we're flipping that way. It's a y-axis flip, then add 3. So looking at our points, let me just draw a graph for this. Got a y-axis and an x-axis. So looking at minus 2, if that goes over the y-axis, it becomes 2, but then I need to add 3, so it becomes 2, 3. So I can just note a point, 2, 3. Looking at 0, 3, well, when you flip it on the y-axis, it's still 0, 3, but I'm adding 3, so it's plus 6, 0, 6. So I can just put 0, 6 up here. And then the last one, 4 is going to flip over to be minus 4, but then I need to add 3. So it's somewhere over here. Just draw that nice and neat. Minus 4 add 3 will be in line with 2, 3. So probably somewhere about there. It's probably not to scale that, so what I'll probably do is move it out a little bit to put it over there and just make my axis a bit bigger. Minus 4, 3. But you get the idea. Now you just draw it in, watching where the turning points are. So 0, 3 was that one. So that's 0, 6. So that's that side. And then this one was the 4, but it became minus 4. So there's my turning point there for that bit. Connecting up to here, turning back round, and just going down. Now you can't quite tell where it cuts the x-axis, so that's fine. Now my curve's a bit messy there, so I'm just going to neaten that up. But other than that, that's it. So just a nice neat curve if you can. And that's a little bit better. But we're done there. SQA Higher Maths 2025, paper 1, question 6. The diagram shows a right angle triangle with angle at Q. Find sine 2Q cos 2Q. We have a second right angle triangle, so we have to do sine 2Q minus R. So sine 2Q is 2 sine Q cos Q. So I'm going to have to know sine Q and cos Q, so I'm going to have to do Pythagoras. 5 5s is 25, 1 1s is 1, that's 26, so that's root 26. So we get 2. The sine of Q is 1 over root 26. And the cos of Q is 5 over root 26. That's a root. 2 times 5 is 10, and 26 rooted times 26 rooted is just 26. Half each of the numbers to get 5 over 13. And we're done there. I'll do part B underneath because I don't want to get too messy. Part 2, cos 2Q. Well, there's 3 things that was that exam paper, but I'm just going to use 2 cos squared Q minus 1 because it's the easiest one for me to use at the moment, I think. So cos Q we already have worked out is 5 over root 26. So that's 2 5 over root 26's squared minus 1. That gives me 2 times 5 5s is 25 over 26 minus 1. 2 times 25 is 50 over 26 minus, well, 26 over 26, which is 50 minus 26 is 24. And that will be simplified to a half of 24 is 12 and a half of 26 is 13. The last bit says find the value of sine 2q minus r. Let me just copy that down. So again, start of exam paper, angle formula for addition. We've got sine 2q cos r minus cos 2q sine r. Well, sine 2q we worked out up here was 5 over 13. So that's 5 over 13. Cos r, well, I can just work that out. Opposite over adjacent over hypotenuse. Adjacent over hypotenuse is 4 over root 17. Minus cos 2q I worked out here was 12/13. And sine r is 1 over root 17. So that gives me 5 times 4 is 20, 13 root 17s minus 12, 13 root 17s, which is 1 fraction is 8 over 13 root 17s. And I think we'll be happy that that is the answer. You could probably take it a step further and rationalise the denominator, but I don't really think that you would have to in this case, but I'll do it for the sake of completeness. If I was to do that, I would do 8 over 13 root 17 times root 17 over root 17. And that would just give me 8 root 17 over 13 times 17. That's 8 root 17 over 211, which is arguably not any simpler. So 8 over 13 root 17, I think, is where we're going to be stopping. SQA Higher Maths 2025, Paper 1, Question 7. Show that x plus 3 is a factor of this, and then hence or otherwise solve. So you can sub in directly, or as most of you will do, you'll use this synthetic division. So you've got 5, 16, minus 1, minus 12, x plus 3, so I sub in minus 3. 5 minus 15. 16 minus 15 is 1. 1 times minus 3 is minus 3. Minus 3 minus 1 is minus 4. Minus 3 times minus 4 is 12, and we'll get 0. So since the remainder equals 0, that implies that x plus 3 is a factor. Well, the way you could say that is f of minus 3 is 0, so x plus 3 is a factor. Now we have to solve it, and it's the same equation. So for part B, we've already got x plus 3 as a factor, so I'll just write that again. And then we've got 5, 1 minus 4, 5x squared plus x minus 4 equals 0. So a little bit of hard factorising if it does factorise. Now, if you're not sure if it factorises, check the discriminant. 1 squared is 1, 4 5s is 20, 20 times 4 is 60, and that's positive, isn't it? 4 5s is 20. If you're not sure it factorises, check the discriminant. If the discriminant's a square number, it's factorisable. So 1 squared is 1, 4 5s is 20, 20 times 4 is 80, that's a minus minus. That gives you 81 for the discriminant. So that means it's definitely factorisable because 9 9s is 81. So a little quick check there. And if you've got a negative number for your discriminant, you know you've got all the solutions. So it must be 5x and x. I was going to write 5x twice there. And it can't be 5 times 4 is 20. That makes no sense because I'll never get back down to 1. So it must be 5 times 1, which is 5. The outside is 5. And then the inside must be 4, taking away 4. Take away 4 plus 1. So that means that x is equal to minus 3. 5x minus 4 is 0. 5x is 4. So x is 4/5. And finally, the other one, x equals minus 1. And we're done there. SQA Higher Maths 2025, Paper 1, Question 8. Given that log a 75 equals 2 log a3, find the value of a. So I need to bring the logs to the same side. Log a 75 minus log a3. And I'll just leave the 2 where it is. Rules of logs. I can combine that into 1 log as I divide. Simplify. 3 25s is 75. That means that the base to the power of 2 is equal to 25. So a is the square root of 25, but just the positive square root, just 5, because a is greater than 0. Tells you in the question, but also it has to be because you don't get a negative base log anyway. And we're done there. SQA Higher Maths 2025, paper 1, question 9. Find the coordinates of the point of intersection of the line with the equation x plus 1 in the circle x squared plus y squared minus 2x plus 6y minus 15 equals 0. So we sub in x plus 1. So we've got x squared plus x plus 1 all squared minus 2x plus 6 times x plus 1 minus 15 equals 0. That gives me x squared plus, square out that bracket, x squared plus 2x plus 1, you can use double brackets for that, minus 2x plus 6x plus 6 minus 15 equals 0. So how many x squares have I got? I've got 2 of them. For x's, I've got 2 minus 2 is 0 plus 6. And for numbers, I've got 1 plus 6 is 7 minus 15, which is minus 8. So we can see that 2 is a common factor. X squared plus 3x minus 4. And hopefully that factorizes to give us x and x, 4 and 1. And it's going to be plus 4 minus 1 to get plus 3 in the middle. So x equals 1 or x equals minus 4. Find the coordinates of the points of intersection. Well, I've got my x's, I need my y. Y was x plus 1. So when x equals 1, y equals 1 plus 1 is 2. So that's 1, 2. And when x equals minus 4, y equals minus 4, add 1, which is minus 3. So we get minus 4 minus 3. And we're done there. SQA Higher Maths 2025, paper 1, question 10. The vectors u and v are such that u is 110, v is 13k. The angle between them is 45. Find the value of k. So a question like this, you're looking at u dot v. And there's two ways to do u dot v. The first way is to times the vector's components together. So the top numbers, 1 times 1, plus the middle numbers, 1 times 3, plus the bottom numbers, 0 times k. So I'm going to start for there. That gives me 1 plus 3 plus nothing, which is 4. So I actually now know that u dot v is 4. But the other formula is u dot v equals the size of u times the size of v times the cos of theta. Well, I know the size of u, size of v, and cos of theta, and I know u dot v is 4, so it's pretty simple now. I don't know the size of u and v, but I can work it out actually. So the size of u is the square root of 1 squared plus 1 squared plus 0 squared. That's root 2. And the size of v is the square root of 1 squared plus 3 squared plus k squared. I can't do much with that, so that's 3 3's is 9 and 1 is 10, 10 plus k squared. So I'll just keep it, it's fine, it's about algebra. So u dot v is uv cos theta, root 2, root 10 plus k squared, cos theta, and theta told us was 45 degrees, and that all equals 4, because I just worked out u dot v was 4. Exact value triangle, 45, 1, 1, root 2. Cos of 45 is 1 over root 2. So that gives us root 2, root 10 plus k squared, 1 over root 2 equals 4. So v root 2's just cancel. So straight away I get root 10 plus k squared equals 4. Well, to get rid of a root, you can do the opposite, which is squaring. So if I square this side, I get 10 plus k squared. If I square that side, I get 16, 4 fours. Quadratic, it's not even a quadratic. I can just take the k squared there and do 16 minus 10, which is 6. And that means that k equals the square root of 6. So what was the question? Find the value of k where k is greater than 0. Okay, it says k is greater than 0, so k is just root 6 as k is greater than 0. In other words, not minus root 6. And we're done there. SQA Higher Maths 2025, paper 1, question 11. The equation 9x squared plus 3kx plus k is 0 has two real and distinct roots. Find the values or range of values for k. So if we've got two real and distinct roots, the discriminant must be strictly greater than 0. Not even greater than or equal to, because if it's equal to 0, it's got two real and equal roots, and it's got two real and distinct. So what is our b? 9k, 3k squared minus 4 times 9 times k is greater than 0. That's 9k squared minus 36k is greater than 0. So to solve something like this, you look at the roots. It's just a quadratic inequality. And that gives me 9k squared minus 36k equals 0. 9k is a common factor to give k minus 4. So k is 0 from the first place, and k is 4. So that answers what the roots are, so I draw it. So we've got 0 and 4. It was a positive k squared. So it looks something like that, where that's 4 and that's 0. And it says we want to be greater than 0, so above the x-axis. Well, above the x-axis, I'm continuing that way, and I'm continuing that way. So our final answer is k must be less than 0, or k must be greater than 4 for the range of values. And we're done there. SQA High Maths 2025, Paper 1, Question 12. Given the y by the x is 6 cos x plus 8 sine 2x, and y is 4 when x is pi over 6, express y in terms of x. So we're told the differential and told to find y, so it's a differential equation. That means that y just equals the integral of the y by the x, which is the integral of 6 cos x plus 8 sine 2x dx. Now we can integrate that by looking at the start of the exam paper. Cos goes to sine, so that's 6 sine x. Sine goes to minus cos, so that's minus cos 2x. And I've still got the 8, but then you divide by the bit differentiated, 2x becomes 2. So it's over 2 here, because of the chain rule. But you've still got plus c as well. Y is 6 sine x minus 4 cos 2x plus c. But when we've got initial conditions, we're told that x equals pi over 6 when y is 4. So 4 equals 6 sine pi over 6 minus 4 cos 2 pi over 6 plus c. Exact value triangle. I think in degrees, and then I turn it into radians. 1, 2, root 3, and that's 30. So pi over 6 is 30. 180 divided by 6 is 30. So that simplifies. And then this fraction here, 2 pi over 6, is pi over 3, which is 60 degrees. And pi over 6 is 30 degrees. So now I've got all my information I need. 4 equals 6. Sine of pi over 6, sine of 30 is 1 over 2. 6 times a half. Minus 4 times cos of 2 pi over 6, which is pi over 3, 60. That's 1 over 2. Plus c. So 4 equals 3 minus 4 divided by 2 is 2 plus c. 4 equals 1 plus c. C equals 3. So we can write our y again with the c back in it. 6 sine x minus 4 cos 2x plus 3. And we're done there. 2025, Paper 1, Question 13. A function is defined a set of real numbers as this. The derivative of f dash x, is x plus 5x, 2 minus x. It says find the x-coordinates of the station points in the curve with y equals f of x and determine their nature. Now you might be thinking, you'll probably make a mistake here, and that's okay, because you're not usually given a derivative until to find the station points, you're usually given y. If you're given a derivative, they've done the first step for you, so you're just finding the station points from there. So for part A, stationary points occur when f dash x equals 0, but I've already got f dash x, so I'll just write x plus 5, 2 minus x equals 0. Solving that, x equals minus 5, and 2 minus x is 0, so x is 2. So there's my stationary points, or at least the x coordinates, which is all we want. I do a nature table, along to minus 5 and along. Then I do another one, along to 2 and along. I'm looking at f dash x. So you're maybe subbing in -6 and -4, and you're maybe subbing in 1 and 3. So up to here, -6 plus 5 is -1. 2 minus -6 is 8. So you've got a positive number here and a negative number here. So you get a negative in total. So that's minus and that's 0. I'm going to expect a positive next, but let's just check. -4 plus 5 is positive. And then 2 minus -4 is also positive. So a positive times a positive is a positive. So that's that one. And then the other side, 1, that's 6. 2 minus 1 is 1. That's positive and positive. That's positive then. That's 0. 3, that gives me 8. So that's positive. And 2 minus 3 is negative. So that's minus. So we've now got down, along, up, along, down. So x equals -5 as a minimum turning point, and x equals 2 as a maximum turning point. And we're done there for part A. Part B, it is known that f is a cubic function. F of 0 is less than 0. And the equation f of x has exactly one solution between -10 and 10. Draw a sketch. Okay, so it's a cubic, so we know it's got 2 turning points, which we already know anyway because we just did it and we've got 2 turning points. F of 0 is less than 0 is saying that on the y-axis, it cuts the y-axis at a negative number. So y-intercept is negative. And the next one, the equation f of x equals 0 has exactly one solution. Now you might have been thinking here, oh, I remember this. Turning point touches the x-axis means it's 1, but that's not just true. It's not, that doesn't tell you that the whole thing has only one solution. If the whole thing only has one solution, it means that it only cuts the x-axis once and once only. So bear that in mind. So x-intercept just once. And we've already worked out our turning points, remember. Turning points are -5 and 2, and we know they're mins and maxes. So for part B, if I want to try and draw a sketch of this, and this is a little bit tricky, I'm not going to lie. There's your x, and there's your y. It cuts the y-axis down here somewhere, and if we go along to 2, we've got a max, and if we go to -5, we've got a min, and between some number -10 and 10, it cuts the axis somewhere. Examine what could happen. Imagine our turning point, this one's a max, is up here. If it's up there, it can never work because it cuts twice. So there you go. If our max was there, just touching and hugging, then it's going to cross over this axis and then it's going to turn around again because that's a minimum. So you're going to touch twice. So the only way it can ever work is if we're underneath there and then we come around and then we turn and the bit where it's cutting the x-axis is over there. So that's what I'm going to do. So we could have something like we go down, we come up, and we go back down. A nice curve like that, something similar to that. And you can see we've cut the y-axis, and we can save it just to be on the safe side. -10 is outside of there, just to show that we know that it's between before -10. But that's the only valid solution. This has been Clear Maths, and today we've done SQA Higher Maths 2025 Paper 1. Hopefully you found that useful. Take care, stay safe, and goodbye.